today is to finish up with data wrangling or data transformations and get to some like data reading and data tidying. Where's my, there it is. All right, so last time we were dealing with the dplyr package to sort of do some manipulation of data sets. dplyr has 5 sort of main things. There we go. Filter, allowing you to sort of reject rows on the basis of their column values. Arrange, which simply orders the rows on the basis of their column values. Select, which just cuts out certain columns. Mutate, which creates new columns. And we did summarize in combination with group by. So I actually lost the, sorry, go ahead.
I'm just going to ask if you can lose packages.
If you can lose packages?
Yeah, I had it installed, and now that I'm trying to run it, it says there is no package.
dplyr. Yep,
It's the
that's
weirdest
weird.
thing.
I got nothing for you.
I'll Google it.
Yeah. So we'll go sort of quickly through each one of those again, quickly to remind ourselves. So all of them involve, as their first argument, some sort of data object, either a tibble or a table, or data frame, I mean. Flights is a tibble with lots of flight statistics in it, or flight data. One column of, and all the functions then take multiple arguments that kind of differ from function to function. So filter takes as its second through nth argument any rules for selecting the rows of the data. So what this one means is look in the month column of flights and keep only those whose value in the month column, keep only those rows whose value in the month column equals 1. Also keep only those days whose value in the day column is equal to 1. These get combined together with sort of a logical and, so it only keeps those rows for which the month equals 1 and the day equals 1. So you get a table out that is just January 1st. We skipped through a lot of this because we'd already covered it. Arrange, again, takes as its first argument a data thing, so like a tibble, and then as the other arguments, it takes named columns in the data that you want to sort by. So first it's sorting by year, then it's going to sort by month, then by day. You can use the desc function to sort things by descending. I don't really look at my data like this that much, so I don't really use arrange typically. Selecting columns, this is when you just have like a huge data set, lots of columns, but you're actually, for the present purposes, only interested in some subset of the columns, so you can just tell it which columns you want. In this section, we also talked about, well, you can use the colon. So if you know the ordering of the columns, you can use the colon to indicate this column to this column and all the other columns in between. You can explicitly say what columns you don't want with a subtract, and it keeps all the other ones. And you can use string parsing to ask about columns that start with some string, or that ends with some string, or that contains anywhere, start, ending, middle, some other string. So you can refer to columns easily that way. If you want to actually just rename something, rename a column, there's a rename function that allows you to rename those columns. It's kind of like select plus well, yeah, no, it's its own thing. It renames the name of the column in place. So the original flights data thing had a column called tailnum, and what this says is it takes that column called tailnum, it replaces it with a new column called tail_num. Also sort of useful in flights, if you just want to reorder the columns, you can use the everything function, and that will put the first ones you put here at the front, and then everything else afterwards. Mutate, we talked about. Mutate will grab, again, a data frame or a tibble as its first argument, and for any subsequent arguments, it's going to create a new column in that data set that has the name that you put on the left-hand side of the equal. So there's going to be a new column called gain. And in that column, it's going to put a result of a computation involving the columns in this original data set. So our delay is a column in this original data set. Depth delay is a column in this original data set. And the subtraction of the two the result of the subtraction of the two will go in this new column called gain. Ditto, speed is computed here as a function of distance and airtime. And mutate will return all the original columns plus the new columns. Additionally, mutate, if you wanted yet a third, so actually this had gain and speed. If you had gain in hours and you actually wanted to create a third thing called gain per hour that refers to these first two things that you were asking it to create, you can do that. It's smart enough to know that, okay, first create this column, then create this other column, then finally create this third column that involves these two original columns. And so again, mutate will return the entire data set, including all the original columns and the new columns that you've asked for. Transmute, on the other hand, will only keep the columns that you've asked, these new columns that you've asked to create. Skip through the section on useful creation functions because we've talked about a lot of these. So finally, we ended with talking about summarize. Summarize will take, again, a data thing as its first argument and create a new data set with any number of sort of computations being performed on the original data set. So here it's asking for just one thing. In fact, I'll start doing this in RStudio. So I guess I need to say library dplyr, library nyc flights. All right, so if I have this and I'll put it in my somewhat OCD formatting, start going, I should get a result. All right, so we've given summarize, in fact, I'll say .data equals flights. Flights as its data object, and we've told it create a new object with a column called delay, and in that column, put the resulting computation that's over here. What is that computation? Well, we're taking the depth delay column and running the mean function on it. So depth delay is departure delay in the flights data. There are some missing values in that data set, hence the use of the na.rm argument to mean. Remember that if you give the function called mean data that includes some missing values, it's going to return just na. We happen to know that there's na in this, sort of in the column, the depth delay column within the flights data set. So we want to tell it to ignore those NAs. So the result is that it just looks at the entire flights data set and gets the mean for the depth delay column.
What was the delay or the delay equals part? Is that making
So
a
what
new
this
variable?
part is doing is it's saying so all these dplyr functions will spit out a data set or a tibble. And so this is naming the column that this computation is going to go into. So as we see, the result is a tibble, 1 row, 1 column, and a single value there. So it's not super frequent that you'll find yourself doing sort of a simple summarize like this. Oh, and by the way, the summarize can be SE or ZE, doesn't matter. Just like color can be OR or OUR in ggplot. Much more frequent is that you want to compute some sort of value from your data set within each of some grouping of the data. So maybe in this flights data set, we've got I know we have multiple years in this data set, so maybe we want to group things by year. So this is where you use the group by function. So group by wants a data object as its first argument. And then as any subsequent arguments, any variables that you want it to group by. So year is something we want to group by. Now this all by itself will just create a, flights. This all by itself will just spit out, again, it's going to be something identical to the flights data set, except that it has this one little line here in the printout where it's telling us that it is behind the scenes going to group by whatever variables it has here if we were to do any computations on this data set.
What does it grouping it by year mean?
Well, it means that if we were to take the data set that's spit out by group by, so group by yields a result, so let's call it by year. So instead of just printing to the screen like I just did by running it without an assignment, let's run it with the assignment.
It's kind of like split file on SPSS.
I don't know SPSS well enough to...
Yeah, it basically just chunks something according to levels of a variable, which is exactly what this is.
But it chunks your analysis by
Yeah, so
so
now,
you're
so
getting to,
if you run
Mhm.
something on by year rather than getting a single mean like we did when we did the other one, it's going to get 2 means,
Yeah.
or
Okay.
however many number of means is the whole same year.
Okay.
So
So it
let's
doesn't show you that now, it's just
Nope.
when you do a computation.
No, so we have to use by year, this object that has been returned by group by, in a computation. So let's do that. I'm going to copy my summarize from above. And instead of dot data equals flights, I'll say dot data equals by year.
Quick question.
Yeah.
When you do data equals flights, that's technically not the name of the data set, is it? 'Cause
It is actually. There's
is it
a
NYC flights 13.
that is the name of the package that provides that data set that
Oh, okay.
sort of stores. Yeah, it's a little bit annoying that they put the data set sort of just in your working space, in your workspace, without really. Yeah, it's doing it behind the scenes. When you do the library NYC Flight 13, it puts in your environment an object called flights.
Oh, okay. So that's where we find out what it's actually called.
Yeah, unfortunately, it's not in your visible environment. It's in like an environment that's kind of hidden from
so
you.
how do we know? The name
Oh,
of it?
oh, look, actually, because look, there's an environment associated with each of the packages. So if I go package NYC
Oh, okay.
flights, it actually shows you what things are there. Oh, cool.
Okay,
I didn't
cool.
know that.
We
It's-
may want to use a different variable because there's only one level of year.
Yeah.
Well,
That's
fine.
pretty easy.
Okay, month. Okay, so instead of by year, we'll name it by month. And we'll sort group by month. And I'll have to, instead of dot data equals by year, I'll put dot data equals by month. And that will give us a mean per month. So you can group by multiple variables. So if I wanted by month and day, put day there. I'll just leave it as named by month. But when I rerun this, it now has a day column because now we're getting a mean per month and day. So this is like lots of flight data. There's lots of flights on every single day of the year. This is just getting the sort of the mean across all the flights on a given day. And in the summarize, we can have multiple things being computed. So this is mean delay. Maybe we were interested in the variability of delay, in which case we'd use the SD. Dep delay. And I happen to know that SD doesn't like missing values in the same way that mean doesn't like missing values. So in the same way that mean has na.rm as an argument that you could use to tell it to ignore missing values, SD has na.rm used to ignore missing values. If I run this a little bit, we'll get, again, some computations for every combination of month and day that it finds. But now we have multiple computations, one for doing a mean, one for doing SD. There's a few more useful sort of summary computations. So if I create something maybe called flight num, and I just wanted to count how many flights are on each day, the n command will count. Oh, expand over. So this column flight num, and you don't give it any arguments to n. It will figure out that I just want to count the number of sort of rows in the piece that it's looking at. So this is the number of rows in the January 1st piece. This is the number of rows in the January 2nd piece, etc. Any other is that pretty straightforward? You're able to group by various things. All right.
Wait, can you go back?
Yep.
Okay, never mind. Sorry.
I was trying to troubleshoot my code and I missed the last part about flight number.
Well, this last column, the computation I'm doing for this last column, I'm using the n function. And what the n function does is it just counts the number of rows. So the number of rows we know is the number of flights that happened on each combination of month and day. So far, we've been creating objects and, well, here what I did is I created this object by month, and then I used it explicitly here in this call to summarize. A increasingly popular way of doing things is save some typing, there's an argument that it highlights the transfer, like the data analysis as sort of a input data object and then a bunch of transformations on that object to yield a result. The way one would do it is instead of assigning the result of group by into an object and then later using that object here, you would not assign, but at the end of group by, you'd put this special sequence of characters, percent greater than percent. This triplet of characters is called a pipe. So what that will do, that will say sort of take the result of this call to group by and give it to the next function. Sort of hand it over, hand it off. Now, since this next function is being given a data set, we don't need to tell it what data set to use. In fact, that would be bad. So we can take off that first argument to summarize, also take off that first comma that was there. And so what's happening is that this call to group by sort of asserts a grouping on flights, yielding a table that it will then pass to summarize through the pipe sort of character there. And summarize will automatically receive that data set, that grouped data set, and know that that's what it wants to look at when it does the computations that you've asked of it. Indeed, it's actually common to not give sort of a named argument to group by for data, but instead, so I'm going to take that first argument out of group by, take off dot data. That means that I have to take off that first comma in front of month, and instead have flights and a pipe. So you start with sort of the main data object, and then each sort of subsequent function expresses what you're then going to do, how you're then going to do things to that object.
Just out of curiosity, why not simply embed your group by function with flights in your summarize and not have all these different
Yes. Okay. So here's another way of doing it. I'm going to put it, I don't know, up here, I guess. Summarize, and you'd say dot data, comma in front of delay, data. We could have supply as the value to the argument dot data a call to group by, in which case we would give group by flights and what did we say? We wanted month. Sure, month, day. The issue with this is that visually it becomes hard to see the sequence of how things are happening, because the last thing becomes the outermost, as if we wanted to do a whole bunch of them, a whole bunch of transformations and filtering and things like that. It then gets, the nesting gets really hard to keep track of. This, it's really straightforward to keep track of what comes before what.
I got an error, could not find function in the pipe function. Oh no, I wrote it wrong. Perfect.
Mm-hmm. So this is somewhat akin to how, when I first taught you ggplot, I taught you to create each layer, assigning each into a new object, and then sort of combine all those objects together with the plus sign to create the final plot object that you then print to screen. This operator, that whole process with ggplot could have been sort of made a little bit less verbose by simply chaining together calls with the plus operator, creating all those layers at once and just putting the plus operator in between them. So you'd have ggplot plus gonPoint plus labs, etc. That latter seems to be preferred by a lot of people. And similarly, this is becoming increasingly preferred, where you have the data object at the outset, and then all the subsequent calls are just receiving the results of previous calls. So that's what the manual switches to, basically, at this stage of the game. Excuse me. Note to self, don't eat well much.
It's a bit unrelated, but my R stopped highlighting code. Is that normal? I don't see a summarize.
Well, you are getting some highlights there. I wonder if
Right.
just the specific choice of highlighting isn't. I don't know. Oh yeah, no, I'm still getting. So in the code appearance, in the preferences for appearance, maybe you're choosing one that's not. I like vibrant.
That's what I'm using.
But online, if you had to go code and then display and then highlight our function calls, code display,
Oh,
highlight our
okay,
function
thank you.
calls.
Ah.
Yeah, 'cause mine did the same thing.
Ah, yes, that's. There are. Yeah, mine may look different from yours because I've set a few different options there. I encourage you to explore those options because they can make things look nicer. All right, so where are we going? Okay, so he starts showing you the pipe way of doing things. So here he does a pipe, and then everything gets stored then into an object that he's then later going to use. But I guess the idea is that rather than creating like an intermediary object for each one of these operations, this grouping, this summarizing, and this filter, he's able to just do it all kind of at once, but in a easy to follow order, and then assign the results back into this object. Has an aside on NA values, because we already talked about NA values and how that works with mean. He hadn't by this point. Did I tell you guys about the is.na function? Getting a nod and quizzical look. Is.na will take, so let's actually look at this. This says take the flights data and pass it to filter. What filter is going to do is it's going to keep anything that meets sort of these criteria. It's got two criteria, this one, comma, this other one. So the criteria refer to the columns inside flights. So there's a depth delay column inside flights, R array column inside flights. And it's passing that column as the value to the function is.na. What is.na does is it will go through every row in the depth delay column and tag it as being either NA, being true if it is NA, and false if it's not NA. So this is going to be a big list of trues and falses. The exclamation mark, who remembers what the exclamation mark does?
Not.
Yes. Yeah. So it just flips the T's to F's and the F's to T's. Because we want to keep those that aren't NA. So we can...
So is.na asks, is it NA?
Yep. So all those that are NA will be T. we want to label those as we're asking it to keep things. So we want any of those T's to be thrown, so we can just say exclamation mark. So, and the same thing happens over here with arrival delay. So what's happening? This is again flights data. Presumably, if there's an NA in either the in the departure delay and the arrival delay, that's a canceled flight. Or any flights that are canceled are not going to have data for departure delay or arrival delay. So we want to get rid of those. So that's a use of is.na. Usually you're going to be using is.na to filter your data. Sometimes NA information, like in your data, you might be interested in like the rate at which you encounter missing data in two groups, or you may want to do inference on the missing values. More often, you just want to toss them because you think that they're missing at random. So this little bit here is showing that you can create an object called not canceled, a data set called not canceled. You can apply, and then you can use that, pipe that in through, group it, and then do a mean. And whereas above we had to say na.rm equals true, if we're using this data set, we've already taken out all the missing data. So sometimes taking out the missing data will mean that you can have a little bit less typing later down the road.
So that pipe command just makes it so you don't need to enter data commands all the
Yeah.
time.
Yeah, exactly. Yeah. In fact, he could have just piped this whole thing, not created, not canceled, and just started from up here and piped the result of this to here. So imagine this word is taken out, and this pipe is put at the end here, and that would have done the full summary. We didn't need to create this not canceled. But I think he uses not canceled again a bunch later on. So yeah, if you're going to use any object multiple times, then it kind of makes sense to store it away in a new. If you're going to use a data set, either the result of filtering or anything like that, multiple times later on, then yeah, store it away in a new object that you can refer to. Saves a little bit of computation and might make your code easier to read. But if you're just doing sort of something one-off, then piping right through is a easier to type and straightforward way of doing things. I already showed you the n command when you're doing a summary. It just counts the number of rows in a given piece of the data, where pieces are defined by the grouping. This is actually.
Can you only give the n command within the summarize function? Or could I just type like variable and then?
Well, summarize and mutate are both creating new things. So all the other ones are like subsetting the data in some way. Summarize and mutate are both creating new things. Mutate puts a new thing on every row, whereas summarize is sort of collapsing the data.
Oh.
So summarize, insofar as it's the only thing that it only really makes sense to do it in summarize. You might be able to do a mutate and use n, but that would just count the entire set of rows in the entire data set. Might not make sense then. So, does anybody feel up to walking through what this is doing? What this one is doing? Okay.
Wait, you wanna?
No, you nodded already.
You wanna explain
Yeah.
it?
Yeah.
So the first line is taking the not canceled data and putting it into a new one called delays, which in delays, they're grouped by tail number, and then it's telling you to take that new one, so delays with a group by tail number, and to summarize it and create a new label called delay, which shows the mean of arrival delay.
Mm-hmm. So tail num, if I taken the time to actually talk, explain up here, it's the just the individual plane. Like each plane has its own number. There's something like 4,000 planes in the data set. So yeah, we're taking all those flights that weren't canceled. So this is an example where we could have grabbed this section and continued to pipe it down here. But presumably if we created this up here to do some stuff, we might as well just reuse it up again. So this is the not canceled flights. Of those not canceled, well, of those flights not canceled, we're going to tell it to group by individual plane identity. So 4,000 groups. Each plane will have flown presumably many flights. So for each plane, then, it's going to compute a summary. And it's going to look at the arrival delays associated with that plane and compute the mean arrival delay. And finally, once that's all done, it'll store it away into a new variable called delays. That's sort of the one quibble I'd have with the explanation you gave just now, because the assignment goes at the once everything is done, then the assignment happens.
Okay, so yeah, I was gonna say the only time delays is actually created is when you end the pipe.
Yeah.
Okay, gotcha.
Yeah. So what's then done with delays? Well, we can visualize it. So getting delays, and the geom we're using is a freak poly. This is like a histogram, but imagine instead of boxes, it's just connected the middle of the boxes. Like imagine doing a histogram with the bars, but then drawing a line from the middle of each bar to the next middle of the next one. That's what a freak poly is. It's actually not great because it kind of hides the choice of bin width. Not easy to see how big the bins are individual, but
Would you plot a histogram underneath that as a separate layer and solve that issue?
yeah, it would just look like exactly as I described, which is a bar with the
But you would see the
midpoint.
edge of each bin. Because if
Yeah.
you center line
Yep.
would go.
Yep.
So the graphs themselves can be overlaid as long as it's all on the same plot.
Sorry.
I was going to say the
Yeah.
individual graphs can be put overlaid on
Yeah.
each other as long as
Yep.
it's the same plot.
Oh yeah. You didn't put this into regular delays. Like all this was to create a variable called delays, which you didn't. I don't know why it's saying that that's the error, but try making the delays variable and see if it
So this is really just giving an example of like creating an object and assigning it, doing something, and then having sort of a meaningful, visualizable result at the end. He actually goes on a little bit of a tangent where he uses the end to count how many flights each plane has done. Here, is it still getting an error for you?
It says
you're missing words like not canceled, group by tail. You should have summarized. Delayed. And then another closed bracket, like an open bracket, and then closed bracket. I think that's your problem.
Okay, now I missed this. Is this what's up here?
No.
So flights is being piped in, but we don't need that yet. It's-
I tried to use that as a troubleshooting.
ah,
This one?
Okay, so what was?
So what was happening here with this
I like
is
like
that you were piping and then you're doing an assignment sort of in the middle of like a chain of pipes and
Oh,
it
it
didn't
doesn't
like
like that. Okay.
Yeah.
All right.
It's weird because it's executes delay, but data is delays.
All right. So the only change that has happened here is that in addition to computing the mean arrival delay for each flight, for each plane, he's also computed how many flights that plane has done by just using the n. Again, n computes the number of items in the group. And that can produce another pretty plot. Does anybody remember from, well, one thing that's salient about this plot is that there's greater variance. There's greater variability from one plane to another for those planes that haven't been on many flights. Kind of see like a funnel shape. Anybody remember what statistical concept that relates to? If we were to do, if we were to do a model that like did just a linear regression in this, we'd have heteroscedasticity. In fact, yep. But this all by itself is sort of conveys a statistical concept without having to do a model.
Sorry, can you? What did they do up there?
Okay, yeah.
Yeah.
So we've computed the amount of delay each plane. Well, we've taken the not canceled flights. We've grouped it in by what plane is doing the flights. So each plane has a number of flights. And for that plane, we've computed across all the flights that it's done, what's its mean arrival delay. And we've also computed how many flights was that mean computed on. So this plot here plots on the one axis the number of flights that a given plane has flown on. So this plane has flown on like 500 flights, more than 550 flights. This one down here is maybe, I don't know, 50 flights, 20 flights. And on the y-axis, it's how the mean delay for that plane was across the number of flights that it had. So all these ones seem to be like it had one flight, and so the mean of its one flight is that value.
So it's like I don't remember what it's called, but it's like the larger your sample size, the closer the mean gets to like the actual mean.
Yeah. Yep. Law of large numbers is the sort of term for me,
Yeah, that one.
and it's a corollary of the central limit theorem. So instead of actually creating an object called delays and then using it here in a ggplot, we actually could have piped the result of this section here right to a call to ggplot and not done a call to delays. This is actually what happens down here. It takes that delays, the thing that we created up here, and it does a filter on it. It says only keep those rows for which the number of flights is greater than 25, and pass that through a pipe to ggplot. So ggplot knows about pipes. It can receive a data object from a pipe, which is nice. And so what have we done? What this has done is it's sort of taken this plot, it's tossed all those data points for which n was less than 25, and plotted the remainder points. So it's a little less sort of extreme looking, but you can still see that central limit theorem results.
Now, if you were submitting these graphs to publications, which one would you show?
Well, you'd explain the full set of choices, and I think this is a substantial sort of scenario. So, yeah.
Well, something wonky was going on. I just with more
Mhm.
variability at one.
Right. Hmm.
Is it possible to scroll back up to the points one?
Yeah, sure.
This one, because I can't get it
Yeah, me neither.
to run.
All right. Do some.
Yes.
Yes.
Our data science, you can copy the syntax.
I know, but I'm just.
So,
Wait, where's delays made?
I wonder, did you? Okay,
Can I
look at
not
this.
run it?
So in this so the way you created things,
Mhm.
you created an object called delays.
Mhm.
Here, when you're using delays, you're referring to the column called delay
Mhm.
and a column called n.
Right.
Did you ask for a column called n? So
That would do.
how would you do it?
Oh gosh. I don't know. Summarize delay. But I don't know what I want it to be.
That plot is visualizing, is
How do you
using
make the
the
first
n command.
Oh,
So the n function, the function named n,
okay. Did you open ggplot?
to count the number of
Back
flights
here.
Yeah.
that each
So
flight is done.
ggplot.
Sorry, each plane is done.
I've been connected.
And you don't need to actually give it any commands because
No?
the
It's just
grouping,
gonna.
the fact that you're
Okay,
passing it
that's grouping.
a
Oh, it should be y equals
table
delays.
that has been
There you
grouped
go.
already, it will
No.
just count the groups,
No.
count the number of flights for each of the groups.
Yeah, there we go. Okay.
Yeah, that was a odd error message because you said x equals n, and it does know about an object called n
Maybe this has to
because
be here.
n is a function as well.
Right.
And so it's saying I don't know what to do though with a function. So if you, yeah, that's just that. If you'd named that say num flights flown, and down there,
Because up there,
it would have given you a more informative error message.
I think
I'm gonna do that. Thank you.
That's what I mean. I don't think that's it.
So the purpose of the dplyr stuff that we've been going through really helps you sort of look at your data, get a feel for it. Really, if you already know like that you want to say filter out missing values, or that you want to select down to some subset of variables that are actually of interest. It can also help you do sort of more exploratory data analysis stuff where you create some sort of summary and then visualize that summary, like we've got right down here at the end. So yeah, but again, this is once the data has been read in. So we're next going to talk about reading in the data. So, does anybody have any sort of general questions about the dplyr family? How to use it to kind of explore data at this stage? No? Yeah. Once. Yeah. So once we get through the data importing and tidying, we can start actually getting you guys to bring in your own data, and this will become a lot more pertinent, I guess. Being able to.
Multivariate data. Because I don't
Not necessarily at first, no.
Okay.
No.
The last data set's very simple.
Yeah.
What if we don't ever have any of those available to us? I haven't checked yet.
There are so in the past sort of I'd say 10, 15 years, the amount, I guess, there's been a sufficient rise in the open data movement that there are tons of data sets
So
online.
if we, for the final assignment, we can use something that's just open.
Yeah, I figured like
If there's something
ideally
that
you want to
I'll
use
do it, but
so that you can get credit for it and
yeah, well,
use
there's
it.
nothing that we're none of my like there might be some I can use. I don't know. I'll check. But like my class,
now in theory
I'm doing right now will be useful.
I'll actually, in the first little bit, I'll be showing you how some things that we would traditionally be calling univariate are actually multivariate. So repeated measures, that's actually a multivariate. It's actually multivariate with some sort of strict assumptions around it. But you can loosen those assumptions and do a full multivariate on it. We'll get there on.
You're so excited. Grinning.
Well, no, I just need all of this multivariate invasion stuff for my actual thesis.
You're sitting through
Mhm.
us learning how
Yeah.
to
Well, I mean, bits and pieces, but
Yeah.
I learned
Well,
code
all
from
the
somebody else. So
yeah,
now I'm
so-
learning new tips and tricks as I go.
Yeah, the dplyr and what,
Mutations,
and all this stuff is it's relatively novel. So it wouldn't surprise me if you hadn't experienced it yet. So what we'll need is the reader package. So packages install reader. Now I should ask ahead of time.
Reader without
READR.
read or no.
We'll start with the idea of just reading in single files. I presume, certainly in my work, I often have one file per person that I'm studying, and so I have to end up reading in multiple files and combining them together. Is that a pretty accurate description of what you guys have, or no? You just have
One mammoth data
okay. Has somebody created that data set by
entering data.
entering data?
I just went into stuff installed and
Okay. Like presumably like something was in paper form as like questionnaires and
Or
things.
like an online survey and then it
Ah.
just gets downloaded.
Oh, okay. Something, yeah. So it's possible that online survey could have produced like individual response files in which you might need to combine, but you've already got a tool that clearly behind your
Like
online.
SurveyMonkey or
Yeah,
whatever.
exactly. Automatically collates it. Okay. Anybody else have an intuition about the typical data they get in their labs, whether it's sort of a single monolithic file per project or one file per participant per project?
one file per participant per project per like session time.
Oh god.
Right.
That's
So-
what you're doing now? No, it's the DALCAD, like my dissertation. Two
Mhm.
people are gonna have like 6 different files. each.
Yeah. Gotcha. Okay.
Great. Lots of fun.
Okay, so we'll talk today a little bit about just the single file scenario. And then next time we'll talk about multiple files a little bit. Okay, so the reader package, actually I installed it, did I run it? Or load it, library reader. So there's some fairly common data formats, comma-separated values, and fixed width values. Fixed width, let's see, widths. Specify fields either by their widths or their positions. So comma-separated is super common. Tab-separated is similarly common. and any other sort of character that delimits the columns, like in a spreadsheet type format, would be read delim.
Can you have multiple delimiters in a read delim?
So
So it's like if you use square bracket to indicate like the end, start and end of a row, you have commas to separate the individual values, and let's say you have brackets to separate different series.
I don't know. Let's check. So I'm gonna look at the help for read delim. So it's a common thing for read delim, read CSV, and TSV. So the delim argument is presumably what we're most interested in. Delim, single character used to separate fields in a record. So no.
So only a single one.
So it only deals with single. However,
We figured it
Yeah, but it took like way too many.
aha.
out. There was a nightmare
Yeah.
with this, and we figured it out.
I maybe would have. Yeah, we can talk about more nightmarish scenarios
Another
as
time.
they crop up. If you guys also, since you guys have also solved it, I'm not gonna spend
No,
time
no,
talking
yeah,
about it.
It was
Um,
a pretty band-aid.
Yes.
It was, yeah. It's ugly, but it worked.
All right. So there's also, let's see.
What is fixed?
Well, if you have, this is a little bit more rare, at least in what I've seen, where the first 10 characters are one column, the second 10 characters are another column. So, like, yeah, it's
Yeah.
that, yeah, not as useful.
So you said the dealing one is the one you would use for spreadsheet.
Yeah, so usually, let's say Excel can export to tab delimited, which would be read TSV, or comma separated CSV. CSV2 is semicolon instead of comma. So all of these arguments take as their first thing a path to where your file is.
Does it read SPSS files too, or just if we click .SPSS?
So there is a whole separate thing that reads SPSS, but it reads it perfectly. So the nice thing about SPSS is it's such a, if you're exporting from SPSS, it has fields that say what each of the columns are. So there is a function. Actually, install the packages. It's called the foreign. At least this is what I've used in the past. SPSS and library foreign and read.spss. So that might be a good workhorse for you guys. If you have sort of existing data sets where somebody has full-heartedly already tried SPSS with it, and you want to apply your more powerful tools, you can read SPSS in very easily. The big thing with like reading in data is like dealing with wonky formatted, like when somebody has done things by hand and put like a wrong character somewhere, or like if you've got a letter in a number column or something like that. It's troubleshooting a lot of that. Something like an SPSS file, that has already been dealt with in getting it into SPSS. Something like an Excel file is less structured than SPSS, so it will be, there will be more nuances to trying to read it in to account for those possible
There are
errors.
also commands that like specifically read XLSX files.
Yep. Where is it? Read X. No. Where are they? He refers to them to it in the. So read Excel is. Haven is, I guess, the newer one. I used foreign, but Haven reads all these things. And there's some other standard data set types that use like databases, so SQL and things like that. So there's some other packages that you can use. I think
Sorry, I didn't mean to interrupt your flow.
no,
Just
no.
curious.
I'm still sort of having the argument within myself whether to teach you guys the read.table way of reading in things, or to trust in Hadley that he's done this well. And
Is it possible to ask a more basic question of data slash heights? How, if we don't want to have to worry about making sure our working directory is set the right way and just have it, start from Christiane Dropbox desktop and go the whole way, how would I do that?
So on a Mac, you can what's called hard code the path, where you
I don't want to have it not run because something's not set.
You would just like copy the icons and windows, but you would paste the...
You can actually grab the full file. So what Christiane is talking about, where'd my window go? There. Is that it? Yeah. So let's say that I'm in, I don't know, I'll go to my work directory, and I will set the working directory, or say I have some file here in my working directory that I want to read in. I can set my working directory to this location, in which case it is run this command, setwd, and now if I look at my console at the top, it says ~_work, and so any files that I refer to at this location are now, I can just refer to them. Say I have a file named, I can't create.
Start that again.
Yeah.
Mine's defaulting to not a fault, like where I use. So.
Yes, so if you, let me show you the way I do things.
I think I grabbed something.
No, I won't say that.
Oh, really?
Okay. My default way of I never open up R or RStudio sort of by going to applications and opening up that way. I open it by opening a file that I want to work with. So let me actually bring up my own Finder window. Let's try, for example, this one. Do I have one already here? Okay, so let's say I've got my project called Ant. The way I have things typically structured is I've got two folders, say, analysis and data. So I'll go into analysis. And there's an R script there. So if I have another session running, so let me close this too. Okay, so I've got no R GUIs running whatsoever. If I double click this, it will open up RStudio. It will open up that file that I double clicked, but it will also set my working directory to that location. So that sort of workflow is what I generally suggest for reading in those, or for setting up your projects and ensuring that you are sort of set the working directory to the right location at the outset. If you try the alternative that Christiane was talking about and asking about was, can't we refer to this full path when we want to refer to a file? So let's actually run with this a little bit.
To do that, and it didn't work, but it could just been me.
So
So, Mike, I take it you find it redundant to hard set the working directory in a line at the beginning of every analysis script?
yeah, because what if you move it to a different computer, or move that folder to a different location on your hard drive? Like that's the downside of hard coding those locations. Is it as soon as you move it, even if like you upgrade to another computer and you use a shortening of your name as your home directory name or whatever, it screws up your script, and so you have to figure this out anyway. So it's better to always just have that procedure of opening directly from the file that you want, and that automatically will set the working directory to the place you want. All right, so I'm actually going to teach you the not reader way of reading in things first. And yeah. All right, so I should email you guys. How's your network connections in here?
Okay today.
Okay today? Actually, why don't we, functionally, let's take like a 10-minute break while I get this to you. Figure out which one I want to give to you. So if you're creating a new directory for a new project and everything?
Like I want to bring in an Excel file, so the folder that it's in is not, it doesn't have a...
So you can just create a fresh R script file there, like...
in the, okay. Whoa.
I've gotten to the point where I have so many, all my projects so if I've got a project that, and of course, as researchers, our projects tend to relate to one another.
Right.
So if I've got sort of an extension experiment from a previous experiment, I just copy the old experiment's code. And so that by definition means that I've got an R file there. So I then will open it and then do what modifications I need to account for the fact it's an extension. Is this any different?
Mike, we also wanted to ask you, are you able to send us an updated syllabus just so we know what dates to have our final project ready and stuff?
Right, because, well, the final days.
But we have 2 Monday final days.
Oh, right. Yeah.
So
So we have
technically
like
the
an
last
extra
day. Is a
day.
Tuesday,
Okay.
If we want to use it or not.
Yeah, yeah. I mean, did you guys want? Because the current schedule has the final day as like the.
But there's also that fall break.
Mm-hmm. Well, the answer is yes. I will send you an updated.
Is the double day the 5th and the 6th or the day for December?
Because Monday is 5th.
Yeah, so it's the 5th and 6th. We're supposed to do Monday twice a
Yes, I think I'll have to.
Oh, I understand what you're talking. How you're saying Monday is. Gotcha. So Tuesday is treated as a Monday.
Yeah.
Just to
Okay.
confuse every single person.
All right.
We gonna have teaching effect on this legend
Hopefully not.
twice.
Because I'm away the 5th and the 6th for a conference, so I'll have to present before.
I guess, yeah. Who has a December conference? That's ridiculous.
CMS Society.
Okay. Right. Send this to you guys.
I need to organize these emails. Outlook sucks.
Just So now that this is my working directory, because on yours you had a briefing. It's right here. So do I just go dot 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 on this? Like this is my working directory.
You should see what his scope looks like. Because I think what he did is he saved the file, the R file in that directory,
But
and
it
then you open that directory.
I did that, but I need to refer to the Excel file.
And I guess you would name the Excel file.
This is also the wrong one.
All right.
No, everyone's okay if I eat, right?
Oh yeah.
Should have asked
Yeah.
prior.
No.
I've eaten like every class so far, so I hope it's okay.
I take it the assignment was just to read the unzipped file you gave us.
Yeah.
Oh, what?
Okay. So I just
Okay.
sent a zip. So I'll get that, unzip, and oh, do that same thing. I guess it would have named it as our workshop, but in there's two folders, Ant1 and Ant2. We'll start with the Ant1 project.
Give me a sec, it's taking a while.
No, no worries.
I have internet, it's like not doing anything.
Yes, that's also where I'm at. It says it's internet.
just ant1 and ant2.
Yeah.
That's all you need.
And are we reading in the data from both files?
Well, they're two different projects. So imagine Ant2 was a replication of Ant1 or something like that. So we're just going to deal with the Ant1 project for now.
I was more trying to figure out what file I actually needed to read in from Ant1.
Well, if you look at Ant1,
Yeah.
there are 20 different files.
Yes, so all of them or just a
Well,
specific-
that's what we're going to do.
Okay.
So if you look in the Ant data set, in the data thing, there's a whole bunch of different files. So we'll eventually learn to read them all in. Any given file, well, there's a CSV one, which is comma separated, and just regular TXT ones. Those are, I happen to know that the TXT ones are tab delimited. CSV is usually reliably comma separated. So but let's start with our analysis. So we can, if we've had RStudio closed, we can now open it again by double-clicking on the main.r. That will open up RStudio, open up that main.r in a section there, and
So just open up the one that says me.
yeah. And critically, it's also set the working directory automatically to be wherever I had that folder, or sorry, the file main.r. So if I open up the files area, it will be showing me where R is looking, that is at the folder with main.r. Now this main.r has already been populated with a bunch of code, a lot of which we'll be ignoring, but including this easy. So the first example though here is a call to the function read.table. We're giving it 3 arguments. First argument is named file. It's got this wonky text here. So we can kind of recognize that here's the name of the data file. This is the name of the folder in which this data file is located. But what's this ... business? What this ... means is I'm currently looking in the folder analysis inside ant1. It's saying go from the folder analysis and go up 1. ... means up 1.
Can you have a ... / ... for up to?
And yes, you can have go up to if you'd like. So up 1 means it's gone, and now it can see both analysis and data. So that's why you have ... data subnode. ... means go up 1. So again, it's looking here. ... means go up 1, and now it can see data, and now it will point at this ant subnum.txt. You can actually look at R files, or sorry, at data files right here in the RStudio console. So if I click on this, it will open it up, but it's not going to look very good. Particularly if it's just a plain text file like this. This CSV that's here, this is another data file. If I click that one, it'll give me an option to either view the file or import data set. Actually, there's some nice, like, I've actually not seen this window before. So this is basically the call to read.table, but, oh, nice. This is like a GUI for creating code that you could then run on lots of things. So you can, it gives you a little preview of what it would read if it read the data according to the parameters you're setting here.
How did you get to this?
Yeah. Okay, so I'm going to cancel. because I actually didn't expect that, and I didn't want to show. I didn't anticipate showing you that yet. Certainly. But the way I got to that is that, again, I had opened the file by clicking main.r in my main file viewer. I then opened up this files pane, and you can either click up here to get from the analysis folder up to Ant.
But when I get to AND, I only have analysis.
No, you don't.
Too. You don't have data showing.
I have data.
I have it too.
I don't.
I don't have any files. 'Cause
Can I also?
So, and also, if I put in the command, it says it can't find it, which makes sense because it's not there.
You haven't extracted the files. You've only double-clicked on them, so.
I start without saving it. No.
This class was for
So you save it, but when it saves,
I'm just distracted once I save it.
I'll go download it.
So, but what we just opened, so that wasn't data, that was a script?
Yeah.
Okay,
the .r file is a script.
okay. So if whenever you're working with data, do you have to have a script to open?
Yep.
Yes, okay.
And when you were talking about like the dot go up,
Yeah.
what do you mean by go up?
If you imagine, like, because on your machine you've got folders and folders inside of folders, so up means sort of to the folder that contains the current one that you're already in.
So this says you go from data to ant to subnum.
No.
Slashes refer to folders.
Mm-hmm.
So there's a folder called subnum, and then the last thing is the file name.
Okay.
So you can kind of read it this way. There's a file named subnum,
Mm-hmm.
whoops, inside a folder named data, inside the one right above where I am right now. So if we actually just go into your, so okay, there's an ant1 folder.
Mhm.
We open it up, there's both of these.
Mm-hmm.
And we go down again, and there's the main. So by opening up like that, it means that R is looking right here. So to refer to the folder that the analysis folder is inside, it's up.
Oh, so why do we need to know that?
Because it's the way to refer to, I mean, you could put you could put your analysis script right in the same place as all your data.
Mm-hmm.
That makes for a messy looking directory if you've got like hundreds of data files or
Yes.
things like that. And also if like your analysis is going to spit out graphs and things like that.
Mm-hmm.
So you might even have like a subfolder here for plots. So it helps keep things clean.
Okay.
For me, you don't have to though.
No, I understand why you would separate them, but why like here, like do
So
we
now-
really need to know like?
Well, if you were going to have your data in a separate directory from your analysis. So if you imagine sort of there's a parent directory here and the two data and analysis, and you open up the file such that your R is looking in the analysis, you have to be able to tell it go up one to the parent and then down one to the directory of the data.
Okay.
Go up to the parent.
So you're really just like minimizing point and click to the extreme.
Yep.
Look right there.
And then frankly, you don't even really need to remember this ever again. Just always be structuring your data sets so that there's an analysis folder and data folder.
Okay.
Analysis folder and
But like initially we won't necessarily have an analysis folder because if we just have data.
yeah, so you just create an analysis folder, and ditto, you won't have like an R file in there yet. I usually just copy a text file and rename it .r, and that will allow you to open up the R console so that's right in, so that the working directory has been set to that place.
Or could you like make an R script that has nothing in it, save it as that?
Yeah.
Maybe like this is where my analysis would be.
Yeah.
Okay.
Okay.
So you guys were able to
Yeah.
download, uncompress, and now you see data. Great. Okay.
Should I see data right now? Or should I just have to
Sorry.
see the
That there is a folder
See
named
that there are
data.
files. Yeah.
exactly.
Okay.
Alright, double check that you guys have your, okay. So, in theory, R will now be able to see, oops, there we go. If you give it this path, this is the path to the file. I happen to know that this is a tab delimited file. So I'm using the sep argument to read.table. Read.table has tons of arguments. Actually, I'll bring up the help. Oops.
So the dot, sorry, you said what goes up to?
Yep. Dot dot means actually just up one.
What?
Yeah. So go to my parent of whatever my current working directory is, then go into another directory called data that's inside the parent. All right, so read.table, file, argument. I can refer to this file. I know that these are tab delimited columns, so I can use the sep argument and tell it it's a tab. /t will indicate tab. And I know that there's a header in this file. Open it up so I can read it. So if we want to look at this data, this so far is just a data frame. It'd be better if we turned it into a tibble, because tibbles are nicer to look at and deal with. So I'll say library tibble.
Oh, tip.
Oh no, did you have to install it again? Or?
No, I said they are.
Sorry?
He
His
is calling
name.
himself a tibble.
You said tables are
So
nicer
he's
to look
saying
at.
that he's good to look at.
Aha. So if I just say A equals, so I'm overwriting what's in A, but it's okay because I'm gonna put inside of it, I think it's as.tibble, maybe? No. Oh, I didn't load tibble in here.
I'm not going to get some auto-complete in that.
No, as underscore, yay. Okay, so reading in with read.table, but that's going to yield a data frame, and data frames are a little bit unwieldy to look at. So instead, I'm going to convert it to a tibble and overwrite A with the tibble version of A. So now if I just say print A, you can see a little nice tibble summary.
Oh, I included that head A by mistake. That's why.
Mine says table 6 by 7.
Mine
Yours
doesn't
is 6 by
open.
7 too?
Oh, I forgot to load table.
Did you maybe open up Ant2?
What is it?
No, yeah, mine's fine now.
What did you do?
I did print A instead of selecting the A equals as tibble and running it.
How did this?
Oh, it should say print.
I just did print A.
And yours didn't work.
It did.
Oh, it did, yeah. That's
It just says
why
that it
it
doesn't.
worked. Originally, I just
Oh.
selected this.
Okay,
Mine says
so when you opened it,
Did you do the print A command?
let me just. So
Oh, no, it works.
Yeah.
I told
Oh, I
everybody
get it.
to
It's
shut
not
down
doing
our
it.
studio altogether
Oh.
and then open it in your regular
By
Finder
clicking.
window,
Okay.
clicking this thing. The
So
shortcut
when
to
it
doing
sets
that
the-
is to do this. And
Okay.
now it's
Now
in
it
the
should
right
work.
place. So
Thanks.
Anybody have anything different still? Okay. So this is actually a data set from a pretty common or pretty popular, no, I guess it's used in neuropsych exams, but test of attention, the attention network test. So it has one main outcome variable, which is RT. Error is another variable that's there. It's got a couple of variables here, Q and flank, that describe something that happens on each of a whole bunch of trials. So there's a subject number, a block number, and a trial number.
Is there only one subject in this?
There is only one subject in this particular.
So subnum 1 is just
Yeah,
subject
it's all
number
one. Yeah.
This is all one. Okay.
I actually might. So I wonder, what does summary of a table do? Oh, okay. So you can take, even as a table or as a data frame, you can do a summary of it. This will give you sort of a rundown of like what it finds in each of the columns.
Cool.
So subnum, it's reading that as a number and it's all ones. Block, it's reading that as a number and it's all, it's 1 through 6. So I saw that for the minimum and the maximum. Trial, it's being read as a number 1 through 48. Q and flank, if you notice here, it's just got some words and then numbers. This is because sometimes when you read things in, R converts, like if it sees a character string, so it had the word center there, it will automatically convert it to something called a factor. You don't really need to know a whole lot about that. Except that this is the default behavior, that it has recognized that there's a limited sort of set of values that it might find in the Q column, and it's just giving you now a tally of the number of rows that have that particular level. So there's 72 rows with center in the Q column, there's 72 rows with double in the Q column, etc. Ditto with flank, it's recognized that there's only 3 sort of unique levels of flank, and each one has 96 rows with it. RT, it's seen as a number, and error, it's seen as a number with 0 and 1. So that's often when you see something that's bivariate, like whether somebody made an error or not, tends to be coded as 0 and 1. So up in the if you look up in the data, so in the data folder, there's a subnum.txt, but there's also a subnum.csv. That CSV is there because it denotes that the columns are comma separated. If we wanted to read in that comma separated one instead of the txt, well, we'd refer to that CSV. So it's file. I want to talk about the CSV. And for sep, I want to tell it that it's comma separated. So if you happen to have lots of data files that are CSVs and not just txt, you do this. And that would read in that same data set. You could say as Tibble, and it's the same data set. So depending on what your software spits out for its data sets, comma separated versus tab separated, or maybe even space separated, you can use the sep argument. Usually most data sets will come with headers on it, so you can say that there is a header. If there weren't a header, you would say header equals false.
So header is just like the columns have names?
Yeah,
Okay.
in the file, the raw data file. So if I were to go in and open up the raw data file, then I guess it opens up in this. It's got a list of names here for the column names. So, skipping down. If we, okay. So if you're following along in this main.r file, you can scroll down to where we have example 6. So it's switched back to reading the table in, assigning it into A. When we're reading the table in, we're reading in the one that's a .txt, and we're specifying that it's tab separated. Let's actually go do something to the file, though. I'm going to go in, open it up. Actually, you can do this right in the RStudio. So, files, open it, and if I change one of these things to like NA, oh, because that's a big number, gotcha. Save. Can run this. Head A is kind of like asking for the same thing that a tibble gives you without having to convert to a tibble at the outset. I'm going to put the tibble stuff in.
Can you change the default value for a missing value? Is it always NA?
Yeah,
or
we're
can
about to do it. So,
Are you altering data files in the viewer?
yep. Because it's, sorry, no, that's not the viewer. This is
Oh.
just opening it as a text file.
Sorry, I didn't realize your windows are arranged differently than mine. I was confused for a second.
Okay. So having added that NA to that entry in the raw data file and reading it in, R naturally reads it in as NA. What if instead of NA, my particular, whatever generated this data in the first place, put NaN there? I'll run this again. NaN is going to be there, but, go Tibble. I actually, wow, that's really impressive. Okay,
Tibble is pretty impressive.
yes, Tibble is very impressive.
We're gonna hate you, but name this one. That was very weak.
I want to make sure that this is truly what I... Oh, actually, I think this is just a general, like that R has... NaN might also be a special thing that R knows about. Let's do little numbers, little letters, NA.
Mine just says NA.
Did you change to NaN and save it again?
No.
That would be why.
I missed something.
Yeah,
What
Okay.
happened?
so yeah, instead of capital NA, let's actually just put it as little NA. Or even like, I don't know.
Did you save exactly what you did with it?
N/A.
Ha!
What's happening?
Okay, so I've gone into the data file.
Yes.
I took the first entry in the this RT column, and I just put little NA.
We're just trying to simulate if there was an NA in there.
That some other software put in, like maybe it's that is not capital NA.
I just mean the NA in general.
Yeah.
Because you wouldn't be changing the data.
No. You're right.
Okay.
Yeah, I definitely suggest that you never touch your raw data. I'm doing it now to pretend to emulate different scenarios of raw data coming in a somewhat unexpected format.
So how do you enter your data? Like in Excel?
A computer, usually I'm having people play video games, so it's being collected dynamically as they're playing the game automatically, and then
Okay.
saved to a text file or save to,
Oh.
if it's like responses on a survey that's on a piece of paper, then yeah, you have to enter it by hand.
What program do you use?
Well, I never do that, but if I were to do that, I'd do like Excel or something where it's an easy spreadsheet, and then I'd export to CSV or something to do the stats on it.
Just out of curiosity, what is your preferred input into our analyses? Just going from a basically text file, or do you prefer?
Yeah, I always, all my data sets spit out text files, so
Okay.
I've actually recently discovered that probably a good idea to also compress those text files, like zip them, each one. They read in faster, and if you happen to, say, wipe your disk partition by mistake,
I know where this is
you
going.
can recover data, but only if it has an identifiable header. And plain text files do not have an identifiable header. Zip files do, so you can.
All right.
Okay, so
Not
we've
from
got
personal
a data file that has been spit out by some other program that uses a string other than the one that R is built to recognize as a missing value. Could be even the word missing, exclamation mark, or something like that. So what happens when I actually do try to read this in with a standard read.table? Oh, I've got missing right there. Great, it's read that in. But all of the other numbers suddenly are being printed with lots and lots of decimal places with them. And indeed, if I look at the thing at the top of the RT column, it's saying it's being treated as a factor now.
Mine doesn't say that.
No? Did you change the value to something other than NA or NaN?
Little NA.
Little NA?
Mine's little NA. And
Did
it
you
says
remember
factor.
to save?
It's coming up as little NA when I print it.
Let me do little NA myself.
No. It did have the digits, though. Mine had all the digits, it just doesn't go back.
Okay. So,
Mine doesn't have that interval factor stuff entered into it.
oh, okay, gotcha. Because
Running.
I understand. I added the line A equals as table.
So yours is the
So I had converted to a tibble. But yes, you can still actually see the consequence there if you did head
Oh, yeah.
A right there. You guys were seeing this. Head is if you have a regular old data frame and you just want to see all the first 6 rows, but all of the columns. That's what head does, is it prints it out. And that's what's in the code there. So I wasn't clear that I was adding that little bit. But you can already see, even if we were just to look at this, that there's something gone on wonky here because it's showing a lot more digits than we're used to. Looking at the tibble representation, we actually see that RT is now a factor column and not a number. It used to be a DBL. If we go up and up, where'd it go? It used to be a double. So what we need to do is just tell R, when it's using read.table, what the NA string is. So the argument name is NA.string. And in my example, I just had little NA. So I can rerun that. And now that little NA has been converted to a big NA.
So NA.string is the command to recode the NA.
Yeah.
But if it was called missing, would you still use NA.string or you would
Yep.
use missing?
Yes.
String?
No, you are correct. That you'd still use NA.string.
Okay.
And this can also work with
If it were
numbers.
missing, if it were number like 999.
Yeah.
Yeah. Let's actually try that. So I'm going to go back into subnum. Instead of NA there, I'll put 999. And I wonder, will this,
Probably won't, but it won't pick that off as a problem. You run it, right?
Oh, no, it worked. So if I don't put that NA string there, comment it out, I run it in. That's read in as a real number.
Right.
If I
But if you do, it won't.
put it in, it's read in as properly an NA value.
So does it always come out as an NA, like a capital NA value?
Yes, if you've told it that that's what missing data means, this is, yeah, because that's how R represents NA. Now, NaN is also something R knows about. It's, what is NaN?
Wait, can I ask one more question?
Yeah.
So, what if the cell is just empty?
Ah, yes, we'll get to that. I guess we should, class is done now, right? Yeah, okay. We'll get to that next time. So if like there's literally no value there, there's, well, quickly, a quick
Because
value
SPSS
there.
puts like a dot or something.
But
In
you're not
Excel,
gonna
it
mess
could
up
be
its rows.
completely empty.
Or in like tab delimiting, and it just puts the.
It's tab delimited, so it still sees that there's 2 tabs in a row there then.
Okay.
So let's actually see. What I didn't save. Save and run. And yeah, if it sees 2 tabs in a row, it just sees that there's a missing value. If that column, if like, oh, where'd it go? There we go.
So then when you're going to say NA string equals, like, quotes with a blank in the
You don't do
middle?
You don't even need
It's
to do anything.
automatic.
It will
It's
automatically
automatic.
recognize that it has seen 2 tabs without a thing in between them. And so it recognizes. Yeah.
Can you do multiple imputation from here?
Not from here. We will be doing that though in the as part of the modeling stuff that we do. Yeah. All right. Well, let's cut it off for there.
Oh, just one final question.
Oh yeah.
How do you display what percentage of missing data you have? Can you do it from here, or is it something else?
That would be something that you'd use your dplyr skills for.
Number.
So you can use is.na to turn the NAs into a logical, and you can count them with sum, or to get a proportion with mean.